Okay, we are now recording, so we are good to go. So let's get into the math now. So 71 and 73, I believe. Okay, sure. And I'm supposed to travel, but I don't know when. Sure, yeah, no problem, Keji. If you find that you can't, you can't attend class because you're traveling, that's totally okay. Just send me an email before class letting me know that that's going on, and we'll figure out anything that you missed after the fact. And that goes for most of you, but again, if most of you were going to miss the class, then I would have had to figure out something else to do. Okay, because I'm really debating on not giving you guys anything to do over break. I feel like you guys have been working really hard, and it's obviously a stressful time. We're coming up into finals, so I was thinking just letting the break be the break. But if most of you guys were going to miss, then I would have had to give you guys something. But if most of you guys are going to be here, then well, you probably don't have to do that. So in any event, let's move on to the math here. So 71, let's start there. Okay, 71, we are given logarithm. So 71 is actually a really good example of knowing your rules, and you're kind of using rules to put things together, break things apart, and then, evaluate from then on. So let's write things down. We have log of 4 plus 2 times log of 5. And the question says evaluate. Now, whenever you see the word evaluate, that generally is indicative of you getting some kind of number answer back, right? Like evaluate means you're going to use some rules, put some things together, and you should just get some final answer being a specific number. It could be a fraction sometimes, it could be, E, for example, it might be an irrational number, but point is that you should get some sort of number back, some value. So, okay, what we're going to try to do is we're going to be trying to combine our logarithms. Why do we know that we can combine our logarithms? Well, when you're trying to combine logs, you're always looking at the bases first. If they have different bases, then you can't do anything with them. You can try change of base formula, and then you could try manipulating them that way, but you can't use your rules straight on. You wouldn't be able to use the product rule, the quotient rule, to try to influence them if they don't have matching bases. But in this case, they do, right? The base here, when the base is not visible, is 10. It's a common log. Both of them are common logs. So we can absolutely apply our rules here. Now, we see that we have an addition going on with our logarithms, right? So when you see addition of two logs who have the same base, then you can use the product rule. But before we can use the product rule, we have a small problem. The problem that we have is that one of the logarithms has a coefficient. If we tried using the product rule right now, it wouldn't really pan out that well. Using the product rule here is going to make things kind of messy. We have this 2, but the 2 is only being applied to this one logarithm. The 2 is not being applied to the log of 4, right? So we can't really use the product rule just yet. What we want to do first is we want to take care of this coefficient. Now, we have a rule for this, right? This is the power rule. So where is this 2 going to go? How do I take care of this coefficient of 2? And this, I'm just asking the class. Anybody can answer. Yes, Keji.
The 2 is going to be the exponent.
Yeah, exactly. We're going to take this 2, and we're going to move it to be the exponent on the value that's in the logarithm. So the value in this logarithm is the 5. So when we rewrite this, this is really the log of 4. We haven't touched the first log, plus log of 5 squared. Right? We took the 2. The 2 is a coefficient. Power rule says a coefficient of a logarithm can be the exponent of the value, and vice versa. If we wanted to go backwards, this exponent could, we could take it out, and it could be the coefficient. So, okay, great. We have log of 4 plus log of 5 squared. And now at this point, you could use a product rule. But before you even do that, why not just take care of the 5 squared, right? We know what 5 squared is, right? So in the same step, I'm just going to simplify 5 squared. 5 squared is 5 times 5, which gives us 25, right? Okay, so now we have log of 4 plus log of 25, and the bases are the same. What, again, we know about an addition of two logarithms is our product rule. Our product rule says that we can add these two, and when we add them, it's the same thing as combining it into one logarithm. And what's going on? Well, again, it's known as the product rule. So what's going on is that we are taking our values and multiplying them inside the one value. You can add and subtract logarithms. Well, adding and subtracting logarithms is by our rules. It's only defined when your bases are the same, right? So if you have log of, in this case, log of 10, then you can use the product rule. You cannot do this, though. If this is what you're asking, Deborah, I just want to verify. If we had log of 4 minus log of 3, for example, this is not equal to one singular log where it's 4 minus 3. Okay, so you can't do this. Remember that the subtraction of two logs is where you use the quotient rule, right? That's indicative of your values being divided. So you could do this. These are equal, but you can't subtract the values. Okay? So hopefully that answered your question. And the same is true for addition. Again, notice here that we have addition of two logarithms. So adding, and then when we condense it to one logarithm, we condense it using our product rule. And product rule says we take our two values, make it one logarithm, and our two values are being multiplied now. Right? So that's product rule of logarithms, and what I showed in red just a second ago was the quotient rule of logarithms. So, okay, we now have log of, and the value inside is 4 times 25. Well, we know what 4 times 25 is, right? We can go ahead and simplify this. This is log of 100. And at this point, you have one of two options. You can either recognize, okay, this is base 10, and you can convert this to exponential form. Again, remember this says evaluate, right? So we're hoping to get some kind of number. So when we convert this to exponential form, how do we convert a logarithm to exponential form? Again, let me just write this over here. What you first want to do whenever you're trying to evaluate a logarithm is you want to set it equal to a variable, right? So you say, okay, well, this is equal to some unknown number. I don't know what this is. How did you get 25? Well, remember that the 2 is becoming the exponent of 5, right? So we moved the 2 over to be the exponent by our power rule, and then it was just 5 squared, and 5 squared is just 25. So just to write the in-between step, this is log of 4 plus log of 5 squared. Yep, no problem. So again, to evaluate a logarithm, once it's in as simplified form as it can be, you just set it equal to a variable, and then we convert it to exponential form, right? Converting to exponential means your base stays the same, so our base is still 10. Your exponent in exponential form is the answer to the logarithm. So your exponent here is x, and it's equal to whatever the value was inside the logarithm. So it's equal to 100. And I'm sure everybody sees this now, right? 10 to some power equals 100. Well, we know what that power has to be, right? And x has to be 2. If you don't see it immediately, that's totally fine. You could always play the game of trying to get the bases to match like we did before. And to get the bases to match, we're just going to manipulate that 100 to be in terms of 10. So this is the same thing as 10 squared. And now remember what we did going back like 2 lectures ago. Now that the bases match, you can set your exponents equal to each other. So you'd set x is equal to 2. You figure out what x is. But in this case, there's nothing else going on, right? So x is just 2. So your final answer to this logarithm, to the original logarithm, is 2. When you add log of 4 plus 2 times log of 5, your final answer is 2. Okay, so that was the first way that you could do it. The other way that you could also go about it is once you got to this point, once you got to log base 10 of 100, you could realize that, again, 100 is the same thing as 10 squared. So we could just write another step here, log of 10 on the value 10 squared. You can use your power rule again to take that 2 out. So now we have 2 times log base 10 of 10. And we have this really nice rule for us that says if our base matches our value inside the same log, then that entire log just reduces down to be 1. So this is the same thing as 2 times 1, and 2 times 1 is again just 2. So regardless how you do it, you get the answer of 2 either way. So the idea here, once again, just to start from the top, is we saw that we had addition of 2 logarithms. We saw that the logarithms had the same base. So we know that we're in business for product rule. But before we can get to product rule, we had to take care of this coefficient. And the reason we have to is, if you guys remember, going back to order of operations, PEMDAS, right? PEMDAS says that, okay, exponents are on a higher playing field than multiplication or addition, right? And even though this looks like a coefficient, we know from the power rule that that's essentially an exponent. So we have to take care of the exponent first before we do, the product rule. Once we take care of the exponent, just like we did here, we moved it to the exponent of 5. We can simplify that. And then we can use our product rule and say, okay, well, if we have two logs of the same base being added together, then all we're doing is we're condensing it into one log of the same base where the values get multiplied. So we ended up with log. We knew it was base 10 because it's a common log. So log base 10 of 100. And you can either convert it to exponential form and get your answer that way, or you could use logarithm rules and, do this where eventually you just get the same answer where your final answer is 2. Does anybody have any questions on what we did, starting from the top here? The top is by far the most important because, this is really how you get going, right? If you got to this point here and you got stuck, yeah, you did most of the work. That's most of the points, but obviously you could still reduce this more, right? The question says evaluate, and this is a logarithm where we can absolutely evaluate it. But as long as you got, these 3 or 4 steps up here, then you've gotten the brunt of the work done. So I just want to make sure that, we're all set with how to use product rule, how to use the power rule, and condensing our logarithms. Okay, I'm taking silence as you guys are golden with this. So we're going to move on here. Okay, 73. All right, so for the interest of time, because we only have about 10 minutes before I want to give you guys a quiz, I am not going to do 73. Again, just because of time constraints. 73, again, is a pretty long one. If you guys watched the lecture, the final example in the lecture was a pretty long example, right? 73 is exactly the same thing. It's just, slightly different numbers. I have no problem going over that with you guys, either on an individual basis, or if you guys want, I can post the solutions to this question on Blackboard. Would you guys want that instead, or do you guys want me to, just go over it at a different time? It's up to you guys. I don't mind either way. I'm not offended if you just want to look at it in Blackboard. Blackboard, sure, I can do that. So later today, guys, I'll post the solutions to 73, so that way you guys can see what I did. So you can take it from there. Again, if you follow along with the lecture posts, it's a 5-step process, right? With your first step being write out 2 equations. So just to at least get you started, we are given 10, 1, and also 1, 2 as solutions, right? And we know it has to be in this form. Y is equal to C plus B log base A of X. You're actually not solving for A in this case. Now, I know in the lecture, there were 2 letters that you were solving for, A and B. They just, in the homework, changed the letters, right? What you're solving for are C and B. And you'll find that when you actually solve this, it doesn't actually matter what your base is. Your base in being A, that number doesn't matter. It could actually be any number. And again, you'll see why when I post the solutions or when you do it on your own. But again, just to get you started, remember your first step from the lecture. Step 1 said, write out 2 equations given your solutions, right? So your 2 equations are, well, this is your X, right? 10 and 1 are your X. And because those are your inputs in an ordered pair, and then 1 and 2 are your outputs, right? So those would be your Y's. So writing this out, we would have 1 is equal to C plus B log base A of, and again, your input here is 10. This is the one that matches this ordered pair. And then you write out another equation where using your same, process here, your output is 2. And C plus B log base A on the value, in this case, 1. And now at this point, what you're going to do is, this is your second step. So your first step was just writing out the equations. Second step is you subtract the one equation from another, right? So it really won't matter which you subtract, one from the other. In general, I like to keep things positive. So I'm going to subtract this guy from that one. So that way I can just have a positive Y. But it really won't matter how you do it, okay? So remember, subtracting equations basically just means you're lining things up in a column, right? So our Y's are in one column, our C's are in another column, and then, the B log A is in the column with the B log A, right? So the idea is you're just subtracting each piece from the other piece. And again, because it's written in not the order that I want it to, I'll just rewrite this down here. Y is equal to C plus B log A. 10, right? So now what I'm going to do is subtract the 2 equations from each other, right? So 2 minus 1 gives me 1. C minus C, well, that just drops out, right? And that's by our process. We want one of the variables to drop out, just like in the lecture, because that way we're only solving for one variable at a time. So C minus C goes away, and now you just have B on log base A of 1 minus B log base A of 10. And what can we do? We see we have a multiple of B in both of these terms, right? So we can just factor that out. So 1 is equal to B times log base A of 1 minus log base A of 10. And from here, you guys can take it from here. Okay, so hopefully this gets you started. This is probably, the hardest part is doing the stuff that you haven't seen before, which is subtraction of equations. But at this point, I would expect you guys to be able to at least solve for B. Okay, so I'll post the solutions later today, and you guys can see exactly what I did, but this should at least get you started, or if you got this far, this should verify that you were already on the right track. Okay, so we have about 5 more minutes. Is there any other question that I can answer from the homework to get you guys there? Maybe like 109C or 109D, because that's logarithm multiplication, and I just want to make sure we're all good on that. 109D and C. Okay, so Keji beat you to the punch, Gabriella. So I'm going to do 109D here. Okay, so we have log base A of the value B times log B on the value C times one more logarithm with the base C on the value A. Okay, so the trick to this is remember that even when you're doing multiplication of, numbers in general, like say you had 2 times 3 times 6, right? You don't multiply all of them at the same time. Multiplication is a binary operation. That means that it takes in 2 pieces of information at one time, right? You can either do the 2 times the 3 first and then multiply your answer times the 6, or you could do the 3 times the 6 first and multiply your answer from that times the 2, right? Multiplication in our brains, we can't multiply 3 things at one time. Right? It's just not possible. So you're going to follow that same procedure here. You're just going to pick 2 things that you want to multiply together. And then from your answer of that, you then do another multiplication. So it doesn't really matter which one you guys pick, because in fact, all of these should be matching up in some way, shape, or form, right? Remember what you're looking for when you're doing logarithm multiplication. You need your base from one logarithm to match the value of another logarithm, right? So let's just say we start reading from left to right, and we just go in this order. Well, left to right says I have these 2 logarithms. So I have log of base A with the value B times log of base B with the value C. So one thing that you're playing to be able to multiply logarithms is you want to find the matching components. You want to find the matching base to the matching value. So in this case, the matching pieces are the log base B, right? We have a base of B in one logarithm, and we have that same value B in the other logarithm. So what this simplifies down to is you're just simplifying it down to one logarithm where everything that's left over just comes across normally, right? We had a leftover piece, the base of A, so that means our base is going to be A. And we had the leftover value of C, so that means our value is going to be C. And that's it, right? So that's how you do the first logarithm multiplication. And now you're multiplying times log C of A, and you notice that, oh yeah, it actually doesn't really matter which pair I pick, right? We can pick either the base of A with the value A, or we can pick the base of C with the value C. Either way, this should work out, right? So if I pick the A as the pieces that are matching, that's totally fine. That means this is going to condense to give me one last logarithm where the leftover pieces are the base of C and the value of C, right? And what do we know about one logarithm that has matching components? If it has a matching value and a matching base, what should this give me? This is just one of my logarithm rules. Exactly, it should just give us 1, right? So our final answer is yeah. And it doesn't matter, again, if you chose C to be the matching corresponding pieces, because if you chose C to be the corresponding pieces, what's left over? Well, what's left over is A base and A for your value. So either way, you just get 1. Okay? So regardless how you do it, 1 is your answer. And the important takeaway from this is understanding how to do the logarithm multiplication. It's only valued. You can only condense logarithms with multiplication if you have matching pieces, one base matching to the value of the other logarithm. If they don't match, you can't do it. And it's that simple. Okay? All right, guys, so it's 11:24. The quiz should be up in about 1 minute, or should be up right now, either way. I'm going to clear my screen here. I'm also going to end the recording right now.